So what we are going to discuss now is the concepts of parent POMs and child POM. So generally when you take any real-time scenario, you will have multiple teams working for a bigger component. So each team may have its own output, its own binaries. For instance, if you are building a WAR file, if you are building a web application, it can contain 3 to 4 teams which are all contributing to the web application. So ultimately the web application will have a WAR file. But there are 4 teams, team A, team B, team C, team D, who are all contributing for that WAR file. So each team will have its own development process. So each team ultimately will develop their code and it will share it as a binary. Generally in this case, since a WAR file will have a set of jar files and HTML pages, each team will have its own jar file and its own JSP or HTML pages. So team A will have a jar file, team B will have a jar file, lower layer team A gives a jar file, team B will use that jar, build on top of that, team C will use the jar given by team B and build on top of that, team D will use the jar given by C and then add HTML pages and generate a WAR file which will be deployed into Tomcat or anywhere. So what I want you to understand here is the stack of development. There are teams in the form of producer-consumer model. I am the lowermost layer, team A, who builds some native code and gives a output as a jar file, native Java code, and gives a, say for example, utility framework, who will generate all the common classes which everybody has to use. Because things like searching strings or any standard methods which all teams want, I don't want each team to implement in their own way. I will develop a core team who will actually give all the framework level methods. Say if you want to search something, use this method what I have given. Or if you want to connect to a database, if each one of them write their own way of connecting to database, it will be pain. There can be some performance issues. So I will write a connection method for connecting to database and I will give for all of you, you use the method that I give. So how can they use the method that I give? They should use my jar file. That is how I want them to talk to me. So I am the team A who provides the utility framework. So I will write all the core methods and I will share with team B, team C, team D. So all of them will use me and write their own code. So team B will use team A and it will have its own layer, and team C will use team B. Like that. It's a stack of development where one team produces, another team consumes. And each team will have its own delivery process, its own build process, because ultimately they want to build a jar file, right? So they have a build process. So they have their own POM.xml, their own Maven structure for building it. So as a build engineer, now you have to consolidate. You should write the parent POM and say, hey guys, first I will build A, then in the team B, I will set dependency for team A. In the team C, I will build the dependency for team B. In the team D, I will put dependency for team C. In that way, I can manage all of you. So that's how you will prepare your approach for building this whole project. A project has multiple sub-teams. In any project you take literally. So you want to generate a root level POM.xml which builds all the sub-teams. So this root level POM.xml does not have any specific goal other than building the child projects. So it doesn't have any WAR file, it doesn't have anything as its output. So that's why I say packaging here as POM. Generally when I use packaging as POM, I use in the context of parent POMs and child POMs. And in the parent POM, I will also specify all the common properties. If I want to use all standard Java compiler for all of them, I will specify the Java compiler version here. So I will say I want to use 1.5 standard across all these teams. So when I specify in the some properties, some plugins, some dependencies in the parent POM.xml, they will be automatically available for the child POMs whenever I run from the root level. So the plugins are configured, dependencies are configured, all the common things are abstracted now. So common dependencies, common plugins, common versions, everything is set. In that way, what I am able to do is, I am able to set standard build process. I don't want one team to build with Java 5 and give a jar. I don't want another team to build a jar with 1.6 version. coming yielding incompatibilities. That is why I have a parent POM.xml which will specify the root level dependencies as well as the root level, the common plugins, versions we will be using in the project. So tomorrow, if a new version of JUnit comes, I need not tell to all of them to update their POM.xml. I will tell them I will update in my root level POM as 4.1.11. Simple. Dot. So I need not worry about third party upgrades happening. I need not keep telling to teams to update their child POMs. I am the one who is responsible for parent POM, and if any new update comes in market which I think makes sense to me to use, I will update in my parent POM only. So here you can see, so that's what is called the importance of parent POM, and here you can see the modules. If you are familiar with any programming, it's like think them as function calls. So when I say modules, first it will build each module. Now it will call this module, it will call this module, it will call what will it call? It will call the POM.xml of each module. So by default, when I say module, if I say this, then I expect that directly under this POM.xml, I expect these folders. But if you have to specify, and if you say this test.api is inside this one, and here you are having your POM.xml, you need to be careful. You need to specify in your POM.xml, you need to specify the path correctly. By default, it will look for a module directly where POM.xml is there. It will look for a POM.xml inside your that module test API and try to execute it. See, the only thing which needs to be properly taken care with Maven is the structure. It wants some structure. It believes that you are following some standard structure. As long as you are following that structure, it's very easy to work with Maven. But if you are not understanding the structures, then it's going to be mess. You need to be careful about managing this path. So when I try to say Maven compile, if you see, if I say I am at test 1, okay, I have a POM.xml. Now let me say mvn compile. What is that? Do you make any changes to this code? Here you can see, when I am compiling, here you can conveniently see build order. First test 1 it goes to test 1 API, it will go to test 1 API implementation, test 1 web app, test 1 web app execute, test 1 web app IT. These are all the sub teams. These are all the sub teams which are all here and which are all mentioned in the so it will execute each POM.xml in this order. It will go to each POM.xml and identify what is the packaging to be done there. Accordingly, it will do the packaging. So how can I set the dependencies of the individual components? See, let me go to any one of them. Let me go to say test web app, test 1 web app. Okay. So this is a component. If you see so what it has is dependencies specific to that component other than the common components, and it can see in the dependency, it is depending on the artifact called test1 API. So it's depending on the artifact called test1 API. So whatever output is coming here, it is depending on that one. So that is how sub-projects will depend on each other. For building this, I want this. So it has mentioned that it requires that in the POM.xml you can see. Now for building this test1 web app, it also requires another dependency. These are not third party dependencies. These are internal team dependencies. You can see it also wants test1 API implementing artifact. Okay, test1 API implementing artifact, this one. If you see this pom.xml, this test1 API implementation also depends on test1 API. So you can see how the dependencies are all maintained. It can depend on third-party libraries as well as it can depend on the internal teams as well. So when you are building it, you need to be careful and build it on the same lines. If you try to build test1 API implementation before test1 API, it will fail because it is expecting the test1 API. See, you are not seeing any version here. Generally for any dependency, group ID, artifact ID, version is here. You are not seeing because by default it will take project version, which is set in the parent POM. You need not specify explicit versions for the things like the project version and so on. It will come defaultly. So in Maven technology, this concept of a parent POM calling multiple sub-POMs is called as aggregation. Is called as this kind of creating modules and calling each module is referred as aggregation. Similarly, a child POM calling its parent to inherit all the properties of parent is called inheritance. This is imagining there are two versions of how you work with this. One, as a build engineer, you will be responsible for building the whole project which contains a set of components. So when you are as a build engineer, when you are building it as a set of components, you use aggregation. You put all the modules in the parent POM. So when you execute parent POM, it will go to each module and it will build each module, each component and resolve its dependencies and finally generate your web application. That is called aggregation. At the parent level, you are aggregating all the modules. Similarly, just imagine you as a component team. As a component team, you want to build your team project. You want to build your component, your own module. So when you want to build your own module, in the pom.xml, you don't have this, you don't have the much of information about versions and all that. You are not putting any versions here. You are only specifying dependencies. So that is because you are assuming the versions are in the parent POM. But you want to, if you build this one directly, you won't get them. So you specify a parent node in your component POM to say, if you are building this component POM alone, without building from root level, which you don't need to do as a component team, you will build your component. But when you are building your component, you can build because there is pom.xml. You can directly go to that component and build. But when you are building that component, it has to get the global properties. That is why as a component team, you should always have this parent node. Then only it will go to root level POM and get those information for you. So this kind of a component team specifying a parent node to go to parent POM and get those information is called as inheritance. So here we understood what is aggregation and what is inheritance. So there is another POM called super POM. So what is the super POM? By default, there is a pom.xml. Whenever you say Maven compile or Maven var package, see, I told you, if you remember, even if you don't put Maven compile, it will do compilation. If you say Maven package, it will generate a var file, provided you set the packaging node in your pom.xml as var. If you say packaging as ER, even if you don't specify any plugin for compilation or for creation of ER, it will take care and it will build it. That is because by default Maven will have a super POM, which is having all these standard plugins available with it. So even if you don't specify that standard, if you don't specify that plugin, it will fetch that from super POM and it will execute. So by default it will be like this. One, when I am building my POM, first it will look for a dependency that are a plugin in my local POM. If not, I will go to parent POM. If not, I will go to super POM. If nothing is there anywhere, then I will throw an error. So This is, though we have not explicitly looked at the super POM concept, but we are already using it. Super POM is there by default whenever you install Maven. All the POMs you write will extend the super POM. So all these things will be there in super POM. So in the parent POM, if you override something from super POM, that will work. And in the child POM, you can specify your own thing as well. So by default, at whatever level you are trying to build, it will look for that. If you have specified any parent node, it will look in the parent. And then it will look for super. If it is not found anywhere, then it will throw an error. So now we are looking at the settings file. As part of understanding the repositories, so if you see, there are 3 types of repositories: local, central and remote. So whenever you want, so Maven local repository is something which gets created when you run Maven command first time. By default, it will be .m2 folder in your user home directory. Okay, if you want to change it, you can go to your Maven installation /cons, and the settings.xml you need to understand what each one is about. First one you can see here, local repository. Okay, so here you can see by default local repository is, if I say local repository, I will take it here. I will say like this: I will say B colon say MVN local repo. Okay, if I say like this, so next time onwards, if I run Maven, column, you can see MVN local repo, everything is getting created here. Okay, so that is how you will use the settings.xml to specify your own local repository. Then similarly, you have a central repository. What is the central repository? This is the repository provided by Maven community. It contains a large number of commonly used libraries, third-party things. By default, the repository is http repo1.maven.org/maven2. You can see here repo.maven.apache.org/maven2. This is where it is by default fetching all the third-party things, from Maven. Okay, so this is the default repository from where I will be fetching all the third-party things. There are people like Nexus, Artifactory. These people also provide the support for service for all the third-party libraries. And finally, there is a remote repository. Sometimes Maven does not find mentioned dependencies in central repository, and you will get build failure or error message. So that's where you have a concept of remote repository. Okay, I'll tell you an example why you need remote repository is for 2 purposes. Just imagine if you are having any WebSphere dependency. Okay, WebSphere is a commercial application. I am just taking an example. It's not exactly WebSphere. WebSphere is you have a commercial application which your company is using, and you want to automatically deploy into that WebSphere. Okay, so by default you will not have that plugin in these public places because it's a commercial and they may not provide outside. But whoever has WebSphere purchased, they will give that Maven node. You use the dependency, you connect to our repository, WebSphere repository, you can get this dependency from us. But we cannot put this in the public places. That is why, but still for building your application, you need that dependency. But where to fetch the dependency from? You cannot fetch it from public dependency. You cannot fetch it from public repository. That is not there in your local cache. That is where you set up your own company repository. All these things, commercial libraries, which you cannot get from the public repository, and neither you have them. So you will set them up in your internal remote repository and say, okay, in case if it is not in public, you get it from remote, because remote contains all those commercial libraries which I want, but which are not available under public repositories. Okay. Next, number 2. That is one scenario where you need to use remote repositories. When you want to have commercial libraries which you cannot have in public repository, you need to set up an internal repository for your company and ask all the teams who want that dependency to refer to the internal repository. Okay. Number 2, other scenario. If you are all 4 to 5 teams, if you see here in our example which we have discussed, if these are all multiple teams, each team is building its own dependency, its own jar, and giving to others to use it. How is it giving to others? Where is it fetching from? In the web app, I have put a dependency, okay, which is good. I am telling this web app depends on this test API implementation jar. Okay, it depends on test API jar. Good. Agreed. But where does it get these dependencies from? Just by putting dependency doesn't solve problem, right? When I have a dependency, I will also have a repository where it can get the dependency from. Where can I put this jar file? How does this web app get this jar file? I specified in the dependency, but it's not in public repository. It's my team jar. How can I put in public? Anybody can use it. That is where the remote repository all comes into picture. So either if I want to use commercial third-party things, or I want to use for internal teams producer-consumer model, internally teams want to consume other artifacts. In either of these cases, the concept of remote repository works. Okay. So how do I set up remote repository? Here I specify a node in the repositories. You can see this repository section here in the pom.xml. Every repository node here will have IDs. Some ID XYZ ABC, and I will specify the URL. How can I point to that repository? And for accessing this repository, if I want to access with any username and password, that username and password I will put in my settings.xml. Here you can specify, I have here servers. Suppose if setting up authentication information to use when connecting to a particular server. So here whatever ID I have put in my repository here, company.lib1, I will go to my settings.xml and I will say I will have a server node like this. I just copy the server node and put it here. I will say ID is company.lib1 and I will say username is anonymous. If I don't have any problems or if I have any authentication set, then I will give username and password here. Okay, this is how I actually can access repositories. So two things. Whenever you want to set up a remote repository, you need to look at two concepts. One is setting up the repository link in your pom.xml, and in the global settings.xml, you need to specify the authentication information to read this particular URL. It can be HTTP, it can be FTP. These are all various ways to fetch artifacts. Okay. So based on whatever protocol you want to use, standardly I will use three things: HTTP, FTP, WebDAV. So in either of these cases, how to authenticate to that information you will not put in POM, because POM is available for everybody. I don't want to put my repository username passwords in my POM.xml. That's why wherever I have Maven installed, I will have the in that Maven installation, wherever Maven is installed, in that Maven installation, I have conf folder, I have the settings.xml. So for accessing those repositories, whatever authentication I need, I will specify the username and password in my settings.xml. So this is how I access my internal team repositories. How do I access my remote repositories? So first it will look for dependency in local repository, means .m2 folder. If not, it will go to central repository, public place. If not, it will look for remote repository. If it is not found in three of them, then it will throw me an error.